Hello guys, a very warm welcome to All India Shri Shivaji Memorial Society's Institute of Information Technology. I am Jamadar from Department of Information Technology. I am here to discuss data structure and algorithms. In that one, we will see today graph representation. How we can represent a graph. Let's first define a graph. Basically, a graph, it's a non-linear data structure. Non-linear data structure. We have graphs like, say, it has a vertices. These are vertices, and this is how we can have a graph. It's a non-linear. So this is vertex A, vertex B, vertex C, or vertex D. Then these are called edges. So we represent it with what? Some set, like it has a set of vertices and edges. V comma E. Say G is graph which has V number of vertices and E number of edges. In this case it is, say the graph is G and vertices are 4, edges are 5 here. The number of edges is AB, BC, CD, AD and AC. This way we have. Now how we can represent in program? How we can feed this graph to computer? How you can input this graph to computer for some processing. So for this there are widely more popularly used methods like use of adjacency matrix, and there is another use of adjacency list. So in one we use a linked list and in the other we use a matrix. Matrix is a 2D array. It is basically 2D array, and this is a linked list. A linked list is used. So what we do actually, we take a vertex A. What are the vertices adjacent to it? So B is adjacent, we will store the link as 1, and for A, C is adjacent, we store the link as 1. For A, D is adjacent. That 3 links are there. For D, A and C only, because B is not adjacent to it. There is no direct way for B. We have to go via C. That's why we don't represent D and B link as 0 we represent. So let's try one example here. The same graph I'll show you with this representation, how we can make use of graph. Say we'll take a 2D dimensional array G, max say 10 vertices are there. You can take any number. This way you will be creating a matrix. You will enter whatever number of vertices are there, that many number of vertices, say n. So we will create n by n matrix. So here we can say it is n, but it should be because since it is an array, here we have to give a fixed size. We cannot use directly the variable n, but we can create a graph for 10 10, but n can range from 0 to 9, any value 0 to 9. This way n is there. You can enter what is the order of number of vertices. Accordingly you can create the matrix. Say in our case we have 4 vertices. That's why our matrix will be 4 by 4. So this is how the matrix will be there. We represent the graph in matrix. So this is, we write all the vertex number in this way as a rows and all the vertex numbers as columns also we write. Now in our graph, this is A, this is B, this is C, this is D, and there is a path from A to C also. So we start A to A, there is no loop here, we represent it as 0. A to B, there is a to C, there is a path. A to D, there is a path. So B to A, there is a path. B to B we represent 0, B to C there is a path direct, B to D there is no path, it is 0, C to A it is there, C to B it is there, C to C it's not there, C to D it's there, D to A it's there, D to B there is no path, via C it is there, but direct path we are talking about, and D to C there is a path, D to D there is no, this way. So now this matrix represents this graph. So it is in computer, it is this matrix means this graph, it is. This is how you represent using adjacency matrix. We can have adjacency list also, that also I will show you here. In adjacency list what happens, we create a linked list. Say this was our graph A, B, C, D. This is a graph. Now what we did, we will create an array of pointers. These nodes, array of nodes we will create. Say this is an array of nodes. Say this is a G1. Array name is say G1 and G2, G3. This is an array G4. Now A, we assume that A is node number 1, B is node number 2, C is node number 3, D is node number 4, like this. Then here we create a linked list head node for A. This is A, node number 1. The node number 1 is connected with node number 2 also, and node number 1 is also connected with 3 also. Node number 1 is also connected with node number 4. It is connected with 2, 3, 4. That this is how it is a one list now, L1. The address, base address of this, say 1000, that will come here in G1 now. And again for another vertex there will be another list. Say the another vertex is B now, 2. So 2 is associated with A, 1, and again 2 is also associated with 3. So this is the last node, we represent it as a null. So let's say its address is say 2000, it is linked list 2, it is linked list 2. So then what happens here, you will be storing address of this one. Same way for node number 3. Node number 3 is connected with all, it is connected with 1, it is connected with 2, it is connected with 4. So this is how the list is created, L3 it is. Let's say its address is 3000. That will store here in 3000 in the pointer. So each vertex for each vertex we represent a linked list here. Now like this, again the node number 4, it is associated with 1, it is also associated with 3. Let's say its address is 4000 and that will come here. Now this will be given to you. Once this is given to you, you can find out what are the edges adjacent to node number 1. So the index will represent node number. What are the edges adjacent to node number 2? From that list you will be able to see. This is how we represent graphs in computer programming. So it is very important, you should know how we can represent. We can represent with the help of adjacency list. We can represent with the help of adjacency matrix. Whenever it is a matrix, it is a 2D array for n by n 2D array, you can say. And then linked list, as many vertices we have, that many linked list will be there. The addresses, the heads of all the lists will be stored in a array of nodes, array of pointers, and that you can use it as a graph. So I hope you enjoyed the session. Thanks for watching. Thank you.